Hey everybody, thanks for checking in. Hope you're doing well. Thanks for watching another math video here. This one will be how to determine if two triangles are similar. And what you'll get from this are the 3 shortcuts for similarity. All right, hopefully you've already watched the video about similar objects, geometric similarity, mostly about triangles was the other video. And so you're familiar with some of the terms that we're going to be talking about in this video. Okay, so just as a quick reminder of that, when two triangles are similar, it means 2 things. Number 1, that all of their corresponding angles are congruent, and number 2, that their corresponding sides are proportional. Another way to say that is that all the ratios of corresponding sides are equal. All right, and you could also say that the triangles have the same, that all 3 pairs of corresponding sides have the same scale factor. That's 3 different ways to say kind of the same thing. All right, so if you have 2 triangles and you do not know if they are similar or not, and you're trying to determine that, well, you do need a minimum amount of information. And that information comes in the form of side lengths or angle measurements. And there are 3 different cases that we're going to talk about, which give us 3 different shortcuts for similarity. Those go by these acronyms that you may have seen before. AA is one of them, angle, angle, or side, side, side is another one. And the last one is side, angle, side. All right, so let's get to work here. Let's talk about angle-angle similarity between 2 triangles. So it is a fact that if 2 triangles have a pair of congruent angles between them, then the triangles are similar. So let me show you in a picture what that means. There's 2 triangles, and I also happen to know for these 2 triangles that they have a pair of congruent angles between them. Okay, so there's a pair of congruent angles there, another pair there. That's all I need. This angle is the simplest, it's the best case scenario for you. It's the easiest way to show whether or not 2 triangles are similar. If they have a pair of congruent angles between them, they are similar by angle-angle similarity. All right? You may need to figure out some measurements sometimes. Sometimes they're not just given to you like this picture does. But remember this, that in a triangle, all the angles add up to 180 degrees. So if you need to subtract from 180 to figure out an angle measurement, you can do that. And by the way, that fact alone tells us that if 2 of the angles are congruent, then the 3rd angle has to be congruent also to the other triangle. All right, so that's angle-angle. It's probably the easiest one to use. So now we're going to swing over to the hardest one to use probably, which is side, side, side. And that says this, that if all 3 pairs of corresponding sides are proportional, then the triangles are similar. All right, so you do have to check all 3 pairs of corresponding sides, and they have to be proportional. They have to have the same scale factor or the same ratio between those sides. All right, let's take a look at a picture here. So I've got 2 triangles. I don't know anything about the angles inside those triangles. All I know are the side lengths. So what I'm going to do to test if they are similar is to make ratios of their corresponding sides. Now, corresponding just means kind of matching up some way. So I'm going to pick the shortest side of each triangle, and those are corresponding sides. So I'm going to take 8 over 5, and that equals 1.6, and that is my first ratio of corresponding sides, okay? So the shortest sides are corresponding to each other. Also, the longest sides are corresponding to each other. So let's make a ratio out of the longest sides. 22.4 over 14 also equals 1.6. Okay, so that's looking pretty good, but we're not done until we test all 3 pairs. All right, so let's test the 3rd pair. Oh, by the way, you notice that I'm putting the large number over the small number in both of those ratios. You have to do all 3 ratios the same way. It doesn't matter whether you pick the large number over the small or vice versa. You just have to do all 3 ratios the same way. All right, so let's test that 3rd pair of sides, and that's 19.2 divided by 12, and that also equals 1.6. Okay, well, since all 3 ratios of corresponding sides are equal, the triangles are similar by side, side, side. So that's what we can say about that. So that took a lot of work. You had to test all 3 pairs of corresponding sides, make sure that your ratios are set up in the same way for each of them. So it is a little bit more work. But one thing that you do get from this is this number that you keep getting for all those ratios. That is called the ratio of similarity, or sometimes it's called the scale factor between the 2 triangles. So at least you figure out that number, which is maybe useful. All right, let's look at the 3rd similarity shortcut called side angle side, and that says this, that if two triangles have a pair of proportional sides and the angles between them are congruent, then the triangles are similar. Notice that the angle has to be in between the two between the pair of proportional sides. All right, so let's take a look here. I've got two triangles there. They happen to be right triangles in this case, so we do know that that right angle is congruent between the two triangles there, and we know that the legs have these measurements here between the two triangles. Okay, so what we got to do to test if they are similar is make ratios of corresponding sides. So I'll take the shortest leg first. 7.5 over 3 equals 2.5. And now I'll test the longer leg. That's 12.5 over 5. And again, I'm going big number over small number. I get the same ratio there, 2.5. Therefore, and with the congruent angles in between those two sides, okay, that's enough to tell me that triangle PGA is similar to triangle LHN by side angle side similarity. All right, so that's my complete similarity statement, and I'm naming the similarity shortcut for this particular pair of triangles. Okay, well, you know what? It's time to summarize here a little bit. I've got a couple of tips here just to kind of wrap things up. Remember that for angle-angle similarity, you only need to know two angles in each triangle, a pair of angle measurements. That's all you need for angle-angle similarity. However, for side-side-side similarity, you need to know all three sides, but you don't need to know any angles at all. But you need to test all three pairs of corresponding sides. Make that ratio of corresponding sides for all three pairs, and that's how you can test to see if the triangles are similar. For side angle side, you need to know two sides, and you need to know the angle that is in between those two sides. And once again, you're testing for proportionality. You're making the ratio of corresponding sides and making sure that those ratios are equal for both pairs. Last but not least here, what I wanted to do was just kind of break down the differences in these shortcut acronyms between similar triangles and congruent triangles, because people get them confused all the time. Congruent triangles are triangles that are the same size and the same shape. Similar triangles, as we've been saying, are the same shape, but not necessarily the same size. Okay, so there are exactly three different ways to show whether or not triangles are similar. That's what we did in this video here. AA, side, 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 and side, angle, side. However, for congruent triangles, you may recall, if you've studied this before, there's 5 different ways to show that two triangles are congruent. They each have those acronyms right there. And so make sure that you know what your goal is to show that triangles are congruent or whether or not to show that they are similar. All right? Oh, and one last thing, that side, side, side or side angle side means that the sides are proportional. They don't have to be the same length, but they do have to be, they do have to have that same ratio. All right? Okay, well, that's it. Hope you enjoyed this video. Hope you got something out of it. I hope you were doing well, too. And lastly, I hope to see you very soon. Thanks again for watching. Bye-bye.